They said only one company on Earth could build the machine behind every cutting-edge chip, ASML. But behind sealed doors in Dongguan, Huawei is testing an EUV-class device the West swore it would never let China touch. Not years from now, right now. It's called LDP. And if it works, Washington's $400 billion semiconductor blockade collapses. No more dependence, no more leverage. Just China mass-producing the chips behind AI, 5G, and next-gen weapons without a single Western tool. This isn't a trade dispute anymore. This isn't just defiance. It's ignition on a battlefield the US thought it controlled. In a secure Huawei facility in Dongguan, engineers are testing a prototype laser-induced discharge plasma system, a device that, according to sources cited in Caixin Global and Nikkei Asia, emits the same critical 13.5 nanometer wavelength used in EUV lithography, the backbone of modern chipmaking. This machine, if functional at production scale, would mirror the crown jewel of ASML's $200 million EUV scanner technology Washington spent 5 years ensuring never reached Chinese soil. U.S. sanctions banned even indirect access to EUV by restricting foreign companies reliant on American IP. Yet despite the global blockade, Huawei appears to have found a technical workaround, generating EUV-class light by vaporizing tin with a high-voltage pulse to form plasma, then manipulating it for semiconductor exposure. Analysts at TrendForce note that if Huawei's LDP system crosses the 100-watt output threshold with acceptable line-edge roughness and throughput, it could represent a foundational challenge to ASML's monopoly. But what's more alarming for Washington? This isn't just a research project, it's one embedded in a vertically aligned chip ecosystem that's already shipping 7 nanometer class hardware to millions of users. So the question now isn't whether the US blocked EUV access, it's whether it's too late. The US government labeled Huawei a national security threat in May 2019, placing it on the entity list and initiating what would become a multi-tiered technology embargo. But the escalation didn't stop at software. In 2020, the Trump administration amended the Foreign Direct Product Rule to block any firm using American tools, including ASML, which relies on US optical and electronic components, from supplying chips to Huawei. Bloomberg reports that this policy directly halted the delivery of at least 5 $150 million EUV scanners bound for SMIC. Though ASML is headquartered in Veldhoven, the company uses US origin components from Cymer and KLA, giving Washington jurisdiction. The objective was surgical sever Huawei's access to sub-7 nanometer chips and stall China's path to high-performance computing. But that move also triggered what Semiconductor Industry Association analysts now call a national imperative in China, an emergency reallocation of capital into domestic lithography R&D. And that decision, meant to kneecap Huawei, may have inadvertently pushed them to build the one machine the sanctions were designed to deny. The LDP system. Huawei is reportedly testing isn't just a theoretical science project, it's a functioning laser source attempting to replace ASML's EUV light engine. According to internal documents reviewed by Tech Insights China, the system works by discharging energy into tin droplets, positioned between electrodes, creating a plasma that emits photons in the extreme ultraviolet range. This approach mimics the physics of EUV, but replaces the proprietary Zeiss optics and multi-mirror collector systems with custom in-house adaptations. The challenge lies in stability and throughput. ASML's NXE 3600D scanners can achieve over 170 wafers per hour, with uptime exceeding 85%. Benchmarks Huawei's system has yet to match publicly. Experts like Dr. Jaeyeon Won of the Korea Advanced Institute of Science and Technology warn that unless Huawei demonstrates beam uniformity and resist compatibility at scale, the system will remain experimental. But the fact that any light at 13.5 nanometers is being generated domestically and aligned with lithographic tooling in Shenzhen labs is by itself a sign that containment may be failing. And there's something else. Huawei isn't building this in isolation. It's part of a three-way alliance with state-funded toolmakers and memory firms, forming a homegrown supply chain that's closing the loop faster than most expected. So the question becomes, how far off is production readiness? Let's reset. In 2018, Huawei was ASML's potential client. By 2020, it became the target of a coordinated international export freeze. The result? Forced self-reliance. According to China's Ministry of Industry and Information Technology, Beijing invested 1.4 trillion yuan, or $193 billion, between 2020 and 2024 into semiconductor self-sufficiency initiatives, more than double the EU's CHIPS Act allocation. Huawei alone spent over $25 billion in 2023 on R&D, surpassing Intel's global R&D budget. This wasn't about national pride, it was existential survival. A single supplier, ASML, held the key to 5 nanometers and below, and once Washington weaponized that choke point, China's calculus flipped. Buying was never an option again after 2020, explains Professor Liu Xiaodong of Tsinghua University. The sanctions forced open a window of irreversible localization. Huawei's race to recreate EUV is not an act of technological bravado, it's a product of geopolitical exclusion. And now that Huawei has re-entered the 5G smartphone race, the incentives to finish that machine are no longer optional, they're systemic. So what happens if the machine becomes viable faster than the world expects? Huawei's return to 7nm production in 2023 using SMIC's N+2 node without EUV marked a turning point. The Mate 60 Pro, equipped with the Kirin 9000S, delivered 5G performance despite US attempts to freeze Huawei at 4G. According to Counterpoint Research, Huawei shipped 35 million smartphones in 2024, up 47% year-over-year, driven by domestic demand and carrier partnerships. SMIC achieved this feat using deep ultraviolet, or DUV, tools with multi-patterning techniques, which, while costly and less efficient, bypassed export restrictions. But it wasn't just about phones. Huawei's HiSilicon division resumed shipments of AI accelerators like the Ascend 910B, built on similar 7nm class designs. And in September 2024, China's customs data revealed a 31% surge in semiconductor tool imports from Malaysia and Singapore, indicating new gray market routes for component acquisition. The sanctions delayed, not destroyed, China's chip roadmap, says Dan Wang, tech analyst at Gavacal Dragonomics. What was intended to sever Huawei's access to advanced silicon, instead, catalyzed a parallel ecosystem. And now, if LDP systems go operational, the West may find its control mechanisms eroded from within. The gap between Huawei and ASML isn't theoretical, it's a measurable production ceiling. Without access to ASML's EUV systems, Chinese fabs remain locked at 7 nanometers, using costlier and lower-yield DUV workarounds. According to IC Insights, SMIC's 7 nanometer yields average below 50%, compared to TSMC's 80% plus for equivalent nodes using EUV. Huawei's 5G Kirin chips, while functional, are still 2 generations behind Apple's 3nm A17 Pro, which powers the iPhone 15 Pro Max and boasts 19 billion transistors versus Kirin's estimated 10.3 billion. The real cost? Efficiency. Huawei's Mate 60 Pro consumes 27% more power, under load, compared to Samsung's Galaxy S24 Ultra, based on benchmarks by Antutu Labs. But that technical lag is shrinking fast. In late 2024, China's Ministry of Science and Technology approved a 20 billion yuan, or $2.8 billion fund targeting domestic lithography R&D, with the goal of producing 5 nanometer capable machines by 2026. As SMIC ramps its N+1 and N+2 nodes and Huawei's LDP tests gain momentum, the question isn't whether they're catching up, but how quickly the EUV firewall is eroding under pressure Beijing was never supposed to withstand. Harmony OS is no longer an experiment, it's a growing operating system ecosystem with strategic weight. As of Q1 2025, Huawei reports 900 million Harmony OS devices in active circulation, with Canalys confirming a 25.6% smartphone OS market share in China, up from just 9.3% in 2021. The Huawei App Gallery, often dismissed as a weak Google Play substitute, now handles over 580 million monthly users and offers 187,000 apps, including Tencent, Alibaba, and ByteDance staples, with developer incentives undercutting Google's 30% commission to just 15%. Pedal Search processes 34 million daily queries across Southeast Asia and Africa, per data from Statista, while Huawei Cloud doubled its IaaS market share in Asia from 4.7% to 9.2% in 18 months, according to Gartner. The company's HarmonyOS 5.0 update introduced cross-device capabilities, phones syncing seamlessly with smart TVs, cars, and wearables in a way Android and iOS still struggle to emulate without proprietary hardware. But outside China, Harmony faces steep resistance. No Google services, compatibility gaps, and geopolitical distrust. Still, for emerging markets with data sovereignty concerns, Huawei's localized, low-cost ecosystem presents a serious alternative, and one Google can no longer afford to ignore. If Huawei succeeds in commercializing its LDP system, it would fracture a choke point Washington has spent 5 years reinforcing. The US-backed alliance blocking EUV exports, consisting of Japan, Optical Resists, the Netherlands, ASML, and the US Core Electronics, has functioned as a multilateral firewall. But Bloomberg reported in March 2025 that Huawei's LDP architecture is now integrated into prototype lithography gear, and patent filings in late 2024 suggest over 17 new optical subsystem designs originating from Huawei's Dongguan R&D cluster. If those patents translate into production hardware, SMIC could begin LDP-based trial runs by mid-2026, bypassing ASML entirely. The implications go beyond consumer devices. Military-grade AI chips, autonomous driving processors, and 6G telecom silicon all require sub-5 nanometer manufacturing. A working LDP unit would sever the West's final leverage, manufacturing throttles, and reposition China as a self-sufficient power in high-end semiconductors. The whole tech war hinged on denying one machine, said Kevin Xu, tech fellow at the Asia Society Policy Institute. If Huawei builds it, the embargo model implodes. But there's a deeper risk looming. What happens if Huawei starts exporting it? The West tried to contain Huawei with every tool available, cutting off Android, blocking Qualcomm, halting EUV access, and banning US firms from selling critical IP. But by Q2 2025, Huawei has re-established itself as China's top smartphone brand, captured over 9% of global telecom infrastructure contracts, and quietly edged back into advanced chipmaking through SMIC's workaround nodes, and a shadow supply chain routed through Southeast Asia and the UAE. According to Reuters, Huawei's revenue rose 9.6% year-over-year in 2024, hitting 704.2 billion yuan, or $97 billion, driven largely by domestic 5G hardware and growing cloud contracts. Even without EUV, Huawei built and shipped 7nm chips. Even without Google, it deployed HarmonyOS on nearly 1 billion devices. Even without Qualcomm, it re-engineered its own silicon. This isn't just survival, it's recalibration under duress. But winning implies finality, and in geopolitics, there are no final rounds. Huawei's position remains fragile. Sanctions continue. Export bans evolve. And LDP remains unproven at scale. The question isn't whether the US lost control, it's whether it still knows how to get it back. We're glad you're enjoying this video. Please like and subscribe. Check out another video that is now on your screen.